Welcome back to another lesson with Emoji Math and Science. In this lesson, we'll see differentiation of products of function. I'll help you see how to derive the formula for differentiation of products of functions, and also we'll use an example to help you understand it better. That said, let's get into class. Now, given that we have two functions u and v and they are product of each other, that is, we have two functions u and v multiplying each other. Now, u itself is a function of f of x, and v is also a function of x, but y is a product of u and v. Now, if you have two functions this way, an increase in x will necessitate an increase in y and will also necessitate an increase in both u and v. So that we'll be saying that y plus a change in y become u plus a change in u multiplying v plus a change in v. Now let's expand this multiplication so that y plus delta y is the same thing as u into v plus delta v plus delta u2 into v plus delta v. So that y plus delta y is the same thing as u now. Let's open the brackets. U times v, that's uv, plus u delta v plus v delta u. I'm opening the second bracket, plus delta u delta v. I can call this my equation 2, and I can call this my equation 1, like we did when we were working with differentiation from first principle. Now let's subtract 1 from 2, so that my y plus delta y minus y, that's minus y here, will be the same thing as uv plus u delta v plus v delta u plus delta u delta v minus uv. Just carve out. Automatically, y minus y will give out. On the right hand side, I'll be left with delta y will be the same thing as uv minus uv will also give out u delta v plus v delta u plus delta u delta v. Like we did, now it's time to divide through. Divide through by delta x, so that delta y delta x will now be equals to u delta v over delta x plus v delta u over delta x plus delta u delta v over delta x. Now as delta x tends to 0, we know that our delta y delta x will tend to dy dx. Also, delta v delta x will tend to dv dx, and delta u over delta x will also tend to du dx. What happens to delta u delta v delta x? It becomes 0. Why? If you look at it there, delta v delta x is already tending to 0. Multiplying another delta v, which is tending to 0, automatically becomes 0. So that this is dy dx here from here will now equals to u dv dx plus v du dx. That's the formula for, now this is how we derive the formula for differentiation of products of functions, also known as the product rule. Let's take an example. My example wants us to differentiate x raised to power 3 multiplying sine x. Now, if you look at this carefully, I can simply rewrite this as y is equals to x raised to power 3 sine x, so that my u will be equals to x raised to power 3 and my v will be equals to sine x. Let's remember that if y is equals to ax raised to power n, y dx will be the same thing as a n x raised to power n minus 1. Now let's look for du dx. It will be the same thing as we have x raised to power 3, that will be x. The coefficient there is 1, the power is 3, then I'll have x raised to power 3 minus 1. That's equals to 3x raised to power 2. And also we have that v is equals to sine x, so that dv dx from a differentiation of trigonometric function is equals to cos x. Now, so that if y is equals to uv from our formula, we've agreed that our dy dx is the same thing as u dv dx plus v du dx. So that here we already have our u, our dy dx is the same thing as our u. Agreed, our u is 3, x raised to power 3, sorry. That's x raised to power 3 into dv dx is cos x plus v is sine x. That's sine x into du dx. That's 3x squared. 3x squared. Now I can simply factorize to make my work neat. This will be x raised to power 2. Now I have x cos x plus 3 sine x. Now with this, I hope you understand how to work with differentiation of products of functions or the product rule. In our subsequent class, we'll take more examples. Thank you and see you in our next lesson.